This is a video from section 12.5 in a Calculus 3 class. The directions say to determine whether the lines L1 and L2 are parallel, skew, or intersecting. If L1 and L2 intersect, find the point of intersection. Let's take a look at number 19. Suppose L1 is defined by the parametric equations x equals 3 plus 2t, y equals 4 minus t, and z equals 1 plus 3t. L2 is defined by the parametric equations x equals 1 plus 4s, y equals 3 minus 2s, and z equals 4 plus 5s. First, are L1 and L2 parallel? Now, here's how this works. V1, which is equal to the vector. Now, the first component of V1 is going to be 2. The second component of V1 is negative 1. And the third component of V1 is 3. So V1 is parallel to L1. V2, which is equal to, now the first component of V2 is 4. The second component of V2 is negative 2. The third component of V2 is 5. So V2 is parallel to L2. Now, here's how this works. If V1 and V2 are parallel, L1 is forced to be parallel to L2. If V1 and V2 are not parallel, that tells me L1 and L2 are not parallel. Now, how can I tell that V1 is parallel to V2 or not parallel? The quickest thing you can do is look at the cross product of V1 and V2. If V1 cross V2 is the zero vector, V1 and V2 are parallel. If V1 cross V2 is not the zero vector, that says V1 is not parallel to V2. Now, with that, I'm going to look at V1 cross V2. So this is the vector 1, 2, 0. And this does not equal the zero vector. So that says V1 is not parallel to V2, and therefore L1 is not parallel to L2. Do the lines L1 and L2 intersect? Okay. Now, let's remind ourselves what L1 and L2 are. L1 is given by the parametric equations x equals 3 plus 2t, y equals 4 minus t, and z equals 1 plus 3t. L2 is given by the parametric equations x equals 1 plus 4s, y equals 3 minus 2s, and z equals 4 plus 5s. Now, if I want to determine whether or not L1 and L2 intersect, I'm going to set 4 minus t equal to 3 minus 2s, and 1 plus 3t equal to 4 plus 5s. And what I want to do from here is I want to solve for s and t. So in other words, I want to find the values of s and t that will produce the same value for y and the same value for z. That's first step. I want to find the value of s and t so that I can get the same y and the same z back. And so let's go back here. I rewrote both equations, and then it looks like the following. T minus 2s is equal to 1, and negative 3t plus 5s is equal to negative 3. Okay? Now, I'm going to multiply the first equation by 3 and add. And what I mean by add, I'm going to add it to the second equation. That's going to eliminate t. And when I eliminate t and solve for s, I get s equals 0. And if I plug s equals 0 in and solve for t, right? So in other words, I get t minus 2 times 0 equals 1. And so what that tells me is t equals 1. And that's what I get here. So when s is 0 and t is 1, I'm going to get the same value of y and the same value of z. Now, from here, will I get the same value of x? So in other words, when s is 0 and t is 1, will that produce the same value of x? If the answer is yes, the lines intersect. If the answer is no, the lines do not intersect, and that tells me that the lines are skew. Okay, so let's come over here. When t equals 1, right? X equals 3 plus 2 times 1, which is equal to 5. When s is 0, x is equal to 1 plus 4 times 0, which is equal to 1. Since 5 doesn't equal 1, L1 and L2 do not intersect. And so we just showed that L1 and L2 are not parallel. L1 and L2 do not intersect. And therefore, the lines L1 and L2 must be skew. And that's how we do problem number 19. If we take a look at problem 20, suppose L1 is given by the parametric equations x equals 5 minus 12t, y equals 3 plus 9t, and z equals 1 minus 3t. And then L2 is given by the parametric equations x equals 3 plus 8s, y equals negative 6s, and z equals 7 plus 2s. All right. Now, V1, which is the vector negative 12, 9, negative 3, is parallel. So we're going to do the same thing, So V1 is parallel to L1. And let's put up here, are L1 and L2 parallel? V2, which is equal to the vector 8, negative 6, 2. This is parallel to L2. V1 cross V2. This is equal to, I claim, the vector 0, 0, 0. And so what that tells me is V1 and V2 are parallel. Now, let's make sure we understand this, okay? Let's draw a picture. Here's the vector V1. Suppose this is the vector V2. Now, we've already established V1 is parallel to L1. V2 is parallel to L2. So I'm going to put L2 over here. If V1 and V2 are parallel, can we agree that L1 and L2 must also be parallel from the picture, right? So in other words, if V1 and V2 are parallel, then L1 and L2 must also be parallel. And we're done. So that's how we do problem number 20. And that's a good stopping point for this video. And so this is a video from section 12.5, and we did problems 19 and 20. Okay, thank you.